you'll probably want to memorize the Pythagorean identities. Now that I'm looking at this, I'm not sure if we're going to need them. Yeah, I think at some point we will. We're supposed to rewrite the given expression as a product of powers of sine cosine. So we're supposed to put this in terms of sine cosine. Before we do that, let's leave the numerator in terms of cotangent because I think something might happen. Look, cosecant is 1 over sine, right? So that's 1 over sine theta all to the 5th. Secant is 1 over, no, never mind. I thought stuff was going to cancel out. It's not. It's not going to be pretty. So we got cotangent is the reciprocal of tangent, right? Tangent is sine over cosine. So cotangent is cosine over sine. So you've got in the numerator cosine squared theta over sine squared theta. That's being divided by, this is cosecant to the 5th theta. So that's cosecant to the 5th theta, that's 1 over sine to the 5th theta. And then secant to the 3rd theta, that's 1 over cosine to the 3rd theta. So we need to flip and multiply. So sine squared and sine to the 5th, that'll get reduced to sine to the 3rd. So it looks like we're going to have sine to the 3rd theta cosine to the 5th theta. Okay, so forget this. We didn't need the Pythagorean identities. We completed the objective. We wrote it in terms of powers of sine theta and cosine theta. So let me see if I can pull up Newton to show you how to enter that. Okay, so this question will need a Pythagorean identity. You can factor out the theta to the 3rd and theta to the 3rd are in both of those expressions. So factor out theta to the 3rd. You're left with 1 plus tangent squared theta. So this is one of our Pythagorean identities, that 1 plus tangent squared theta is secant squared theta. And that's it. I think that's all they're looking for. So let's find cosine theta. Theta is in quadrant 3. Right, it goes 1st, 2nd, 3rd quadrant. That's a 3, not a V, sorry. So we know our angle is somewhere over here. And we know that, and it's a reference angle. Sorry, well actually theta goes all the way around. So I should be more clear about that. Theta goes all the way around. Tangent of theta, tangent of whatever this angle is, so it means from the reference angle, the opposite over the adjacent is square root of 7 over 21. So you could just write this to be the opposite, because that's what tangent is, and this is the adjacent. Just note that we're not dealing with the unit circle anymore. Okay. So if we put that in there, then we can use the Pythagorean theorem to find the hypotenuse, right? A squared plus b squared equals c squared. So we got 21 squared plus square root of 7 squared is 7. I don't know what 448. Okay, so c equals the square root of 448. And we can definitely simplify that. Maybe we can take out a 16. Yep. So that's square root of 16 times square root of 28. I think we can simplify that even more. Because the square root of 28, 28 is divisible by 4. So that's 4 times the square root of 4 times the square root of 7. So 4 times 2 makes 8. We got 8 square roots of 7 here. 8 square roots of 7. Okay, so now we're ready to say what cosine of this angle is. Oh, and I should put negative and negative here. Okay, because we're going on the negative on the x-axis, negative on the y-axis. So cosine is the adjacent divided by the hypotenuse. Right, this is the adjacent to this reference angle. This is the opposite, so this is adjacent, and this is the hypotenuse. So if we rationalize the denominator, multiply the top and the bottom by square root of 7. And then 8 times 7 makes 56. There's our simplified answer, I think. Yeah. No, it's not simplified. I forgot basic arithmetic. The top is divisible by 7 and the bottom is too. So that's -3 squared root of 7 over 8. You divide 56 by 7. There's your simplified answer.